Okay, in order to use this auto titration setup, there is a GUI in the system where the student is able to key in all the values and parameters relevant to the experiment. Following which, as the auto titration starts, the camera will move down to find the initial water level. Afterwards, the stepper motor starts to dispense the titrant. A video feed is used to show the current color of the solution in the beaker. As we approach the endpoint of the experiment, we start to monitor the color in the computer vision. At exactly the endpoint, the mechanism triggers and the liquid stops dispensing. Following which, the student selects that as the correct endpoint and the camera moves down to detect the water level in the burette. After the water level has been successfully detected after the experiment, the height that the actuator has moved will be used to calculate the volume of liquid dispensed from the burette. From the volume of the liquid dispensed from the burette, the volume of titrate is then used to calculate the concentration of the titrant from the parameters that were previously inputted by the student at the start of the experiment, concluding this entire auto titration process.
Consider a construction site where manual labor is a part of everyday life. Existing trolleys are not ergonomic and can cause enormous strain on the user when maneuvering heavy loads.
project aims to build a 3D scanner that utilizes photogrammetry. Why photogrammetry, you might ask? Well, current 3D scanners that utilize lasers are either very expensive, costing a few $1,000s, or are unable to produce textured models. Using optical data from camera photos, photogrammetry offers a low-cost option to generate textured 3D models of objects. Our product is almost entirely 3D printed and utilizes a 16 megapixel ArduCam camera to take pictures of an object at different azimuthal and altitudinal angles for complete hemispherical coverage. With a self-developed web app, we are able to initiate this entire process with a simple click. To get pictures from the different azimuthal angles, we use a stepper motor to drive a bevel gear housed in here, which turns the stage by approximately 15 degrees, followed by a short delay for the camera to focus on the object and take a photo. This is iterated until 24 photos of the object are taken at unique angles. Once 24 pictures have been taken, the camera arm is driven directly by the stepper motors to rotate, causing it to move up to an altitude of 20 degrees to capture 24 more photos. This entire process repeats until we have the 24 photos of the object at 0, 20, 40, and 60 degrees altitude. Once all the photos have been taken, we can transfer the entire set of images onto our laptop and generate a model directly. The Lightbox enables us to alter the brightness of our objects, such that good scans can be taken of both dull, shiny, and translucent objects. With a modular approach towards designing our individual components, parts that become defective through wear and tear can be replaced with ease. This also makes it possible to attach alternative imaging devices like optical microscopes and ultrasound transducers for more specialized purposes. And just like that, we can generate a colored model for whatever purposes we desire.
Hello, this is Group 2 presenting on our M&T project, a cone laying robot. These are slalom cones. They are normally set up in a straight line for roller skaters to practice moving through them. However, setting up these cones by hand can be time-consuming, tedious, and the distance between the cones may be inaccurate when set up by hand. Thus, our cone laying robot aims to automate the process of laying cones in a straight line. We also want the user to be able to customize the number of cones and the distance between the cones. Lastly, we also want to allow the user to control the car to customize the cone laying locations. We took inspiration from a bowl denester mechanism on YouTube. As you can see, one stepper motor rotates to drive a pulley belt, and the rotational force of the pulley belt turns pulley balls with separators, hence dispensing the balls neatly one by one. We drew inspiration from this animation and came up with a design sketch. However, our initial design was not ideal. We had to make a lot of changes over time, as seen in the many redesigns we had of our ring. Eventually, we got the cone dispensing mechanism to work, and here it is in action. And here is another angle together with the Bluetooth app that we developed. Here is the interface of our Bluetooth app. In the top left hand corner, there is a sun or moon button which just allows you to change the light or dark theme of the app. After you press the connect button, the app prompts you to connect to the Bluetooth module that we installed in our robot. Once connected, you'll see this interface. You can move the joystick around to allow the car to move forward or backwards. To drop just one cone, you can press the drop cone button in the bottom left hand corner. If you would like to program the number of cones to lay and the distance between each cone, you may press the top right hand corner button. And that's it. Our product is easy to use and intuitive. As you can see in this clip, the robot is able to dispense 5 cones, each 60 cm apart, just as we had programmed it to do in our app earlier. Thank you!
Make me higher. You can make me right. Every day, every day, every day, every day. Just another day of love. Just another day of
Save another day for me. Save another love sensation. Save another day for me today. Save another day for your love. You can make me higher. Every day you can make me right.
皆さんお立ち会い。これだけは本当に目ん玉ひんむいてよく見ておいた方がいいぜ。こんな近くで直に見られるチャンスはめったにないから。これぞ本物のドリフト。
So something weird lah. When I try to put them together, like they will stick. Like I can try to balance them, but they will try to stick together. But if the bottom is some magnetic material, it somehow floats. Okay, so weird shit. I can turn it, and it can repel even more actually, but it somehow repels down and then it stops repelling. But if I turn it a certain, actually I think it just repels all the way. Oh wait, I thought it would attract at least, but no. But it doesn't repel all the way, like, cause I can turn it and it can actually repel more. I'm not even pushing it up, but it will pull itself down until it repels. Okay, turns out if I press it down, it actually stays down. And then I have to, yeah. Okay, so a new discovery. Even if there is no material between, if I spin it, it levitates for a while.
I don't know why I think that much is fucking make me sad. Hey yo! It was crazy. Just when I said it, you fucking play this song?
So we want to like rewire it so that
no, because this is the proper connector. This connector is for your that.
as in I cut like this part. Cut this open.
You can wire from the bottom what?
I think I what solder the thing.
Yeah.
But now we just need to change it.
The magnet is getting attracted to that.
So dangerous.
It's very dangerous. Honestly, it's tilting more than it's reflecting.
Hello, today we'll be presenting our prototype, Paul Pulse Pound Pantry. We aim to target the root cause of knowledge gap and create a product that first, quantifies obesity in dogs, secondly, is easily operable by owners at home, and thirdly, reduces overfeeding. Our prototype has 4 components. Firstly, the bioimpedance analysis, secondly, the weighing scale, thirdly, the food dispenser, and lastly, the website. Our first component, Paw Pulse, is the bioimpedance analyzer, which measures the body fat percentage. We first calibrate it by using a 510 ohms resistor that emulates a human's body. We also use a feedback resistor of 200 ohms. After that, we conduct a frequency sweep every 900 Hz for 100 increments starting at 10,000 Hz. After calibration, we replace the 510 ohms resistor with our ECG pads. We place these ECG pads at the arms and legs of one side of the body. After that, using the same settings, we conduct another round of frequency sweep. This gives us a curve that allows us to ascertain the impedance at 50 kHz, which will allow us to find out what is the body fat percentage. Next, we have Paw Pound, our weighing scale. We design our weighing scale with certain specifications tailored toward dogs, such as the large weighing platform to accommodate dogs of all sizes, a corkboard to hang the extractions, as well as 4 load cells placed in a Wheatstone bridge configuration to improve accuracy of weight. Firstly, we calibrate the machine by using objects with known mass. After that, we weigh another object with a different mass to ascertain the accuracy of our calibration. Finally, after calibration is done, we can use the weighing scale to measure the dog's weight, which will help us in calculating the body fat percentage. Now we have our third component, Paw Pantry, which is our dry food dispenser. We designed it so that it is Bluetooth operated, so that you can control it using your phone. And to ensure that an accurate amount of kibbles are dispensed, we ensured that the motor has a 3-speed mode. Firstly, we calibrate the machine. After that, we put in the mass of food that we want to dispense. The dispenser will dispense food quickly at first. However, as it gets closer to the desired mass, it will start to slow down. And when it gets very, very close to the desired mass, it will slow down even further. This allows us to dispense food accurately with a margin of 1%. Lastly, we have our website, which combines all 3 different components. Our website has helpful information, such as some of the ways to get the measurements needed for the impedance analyzer. In the website, by inputting the Excel files we get from our impedance analyzer, we can get the impedance results. We can also input the dog information to calculate the dog fat percentage. It will also give us the recommended daily calorie intake. It also allows us to input the kibbles information so that we are able to get an accurate mass of food to be dispensed per day. That's it for our prototype. Feel free to visit our blog for more information.
Ever been in a situation where there's a blackout? Or you are out camping and there is no fire or electricity, but you just want a nice cup of coffee? Introducing Mac Heat, not affiliated with McDonald's. It uses the power of magnets. More specifically, eddy current, also called Foucault's current. How it works is that we have spinning magnets. Due to the alternating pole of the magnet, it will induce a fluctuation in the magnetic flux. This will induce EMF, also known as Faraday's law of electromagnetic induction. The induced electric field may create conduction currents inside a conductor, like a plate, or displacement currents in space. The circulating electric field induced by Faraday's law generates a magnetic field according to the Maxwell-Ampere law, creating a feedback loop between electric and magnetic fields. A changing magnetic field induces eddy currents in a conductive material, Faraday's law. These eddy currents collide with the material's molecules, transferring energy. The molecular motion increases, raising the material's temperature. Heat transfers to nearby mediums, e.g., water, through conduction. This process is efficient for applications like induction cooking, industrial heating, and medical treatments.
Introducing our automatic drip bag packer.
창이가 좋아하는 랜덤 게임, 랜덤 게임, 게임 스타트. 아파트 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 kissy face sent to your phone, but I'm trying to kiss your lips for real. Red hearts, that's what I'm on, yeah. Come give me something I can feel. Don't you want me like I want you, baby? Don't you need me like I need you now? Sleep tomorrow, but tonight go crazy. All you gotta do is just meet me at the 아파트 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 아파트
It's whatever you like. Turn this opposite into a club. I'm talking drink, dance, smoke, freak, party all night. Come back, girl, what's up? Don't you want me like I want you, baby? Don't you need me like I need you now? Sleep tomorrow, but tonight go crazy. All you gotta do is just meet me at the 아파트 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 아파트
Hey, so now you know the game. Are you ready? Cause I'm coming to get you, get you, get you. Hold on, I'm on my way. Yeah, I'm on my way. Hold on, I'm on my way. Yeah, I'm on my way.
Don't you want me like I want you, baby? Don't you need me like I need you now? Sleep tomorrow, but tonight go crazy. All you gotta do is just meet me at the
Just meet me
Just meet
Produced 1.5 bags in 1 minute 28 seconds, faster than taking 2 minutes 27 seconds to make one drip bag by hand.